Hello, my name is Michał Grochecki, and I'm a machine learning engineer at DeepSense AI. Today, I'm going to talk about how we can leverage modern tools to help us with understanding and exploring data. The reason I chose this topic is that I believe sometimes we may be so accustomed to doing things manual, tedious way, that we are unaware that there are tools designed to help us in the process. And I wanted to showcase some of those tools. I'll start with a short introduction on exploratory data analysis. Then I'll talk a bit about what the traditional approach to EDA and data visualization was. I'll also present some automated tools that make EDA a bit easier and less cumbersome. And I finally focus on how the rapid development in the LLM space can help us with analyzing and visualizing the data. In the end, I'll compare presented approaches and give you a short summary. So I have this neat definition from IBM's article on EDA that says that it can be used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. Essentially, EDA refers to the process of performing initial investigations on data in order to discover patterns, spot anomalies or outliers, test hypotheses, and to check underlying data assumptions. As I mentioned before, visualization is one of the key points when performing EDA. I believe that there are three main factors that need to be taken into account for visualization to actually be useful. First of all, we have to know what particular data we want to visualize. Then we have to know how to actually create the plot. And finally, we have to know how to interpret the results so that we actually draw useful conclusions from them. Satisfying those conditions can require a lot of effort from us, especially when we are limited to using traditional tools. And speaking of traditional tools, let's take a quick journey into the past and see what the traditional approach to data visualization was. Plotting libraries have been there for ages, but the thing about them is that you do actually need to know what you want to plot and how to do it. So three most popular libraries for this purpose are Matplotlib, Seaborn, and Plotly. Matplotlib, the OG of the plotting libraries for Python, offers an extensive range of plotting capabilities, is highly configurable, and the generated plots are rather ugly by default. Seaborn is built on top of Matplotlib. It provides a high-level interface for creating informative plots and integrates nicely with pandas. Also, the generated plots are aesthetically pleasing out of the box. And Plotly is the newest one of the three. It also provides a wide range of chart types, does also integrate with pandas, and is designed for creating interactive visualizations. Now let's talk a bit about automated tools and how we can delegate part of our work to them. So why is manual approach cumbersome? While analyzing and visualizing our data manually gives us a lot of flexibility, it does require us to determine which plots are potentially insightful, determine what kind of plots are suitable for particular data types, write the actual code for generating the plots. So to put it shortly, it requires us to make a lot of effort, which goes against the topic of today's talk. A way to mitigate that would be to use a library that looks at your data and streamlines EDA by automatically generating all kinds of visualizations and provides comprehensive insights. So going back to the chart, I've shown the what to plot and how to plot it parts would be partially taken care of, which in result would help us in drawing conclusions. First tool I'd like to talk about is called YData Profiling, previously known as Pandas Profiling. It's said to be a leading package for data profiling that automates and standardizes the generation of detailed reports complete with statistics and visualizations. This quote comes from their documentation, so you might want to take it with a grain of salt, but I'd say it pretty much delivers on this promise with just one line of code, which I showcased on the slide. It generates comprehensive report containing insights, visualizations, data quality assessment, And it can also handle different data structures such as tabular, time series, or text. And another package that works in a similar manner is Sweetviz, which again describes itself as an open source Python library that generates beautiful high density visualizations to kickstart EDA with just 2 lines of code. I show you those tools in action, but I'd like to start the demo with the old school approach, shall I say. So let me share another window. So let's do a short demo during which I'll show you what the process of manual and automated analysis might look like. I'll use this random NBA and New York City Airbnb listings dataset taken from Kaggle, and let's see how we can examine it. So first of all, we can run a head method to showcase the first few rows. We can examine what kind of columns we're dealing with. So we can see that we have the columns like neighborhood group, neighborhoods, coordinates, room type, price per night, etc., etc. We can view the shape of the data frame. We can run the info method to examine the data types and the count of non-null values. We can count null values for each column. We can run the describe method to get some basic statistical analysis, including count, mean, standard deviation, as well as percentiles. And we obviously can run some visualizations on the data set. So a few examples of the visualizations we could run would be a count plot showcasing the distribution of listings per neighborhood group. So that tells us pretty much that the most popular places to for the Airbnb listings would be Brooklyn and Manhattan. We could do the same for room type and see that the most popular ones are private room or entire home or apartment. We can, for example, do a histogram of price, and this one is done using the Plotly library, which is interactive. So that gives us an advantage of zooming on the particular part of the plot that is of a particular interest to us. We also get some additional information on hover, like bin range, for example. Another example of visualization would be a box plot showing us the distribution of price per neighborhood group. Or, for example, we can do a box plot of availability per neighborhood group, which tells us that the Staten Island is the neighborhood group or borough that has the most often has the available listings on Airbnb. So that we obviously did need to perform all of these actions manually. The options for this analysis are countless and endless. It's only our imagination that limits us in this matter, but it's obviously time-consuming. It does require some work. The example I've shown is pretty basic, so the code for generating the plots also isn't very complicated, but still does require us to perform all of those actions manually, which we do not always want to do. So the alternative would be report generated by the YData Profiling library. Again, as I've shown, it's only a matter of a single line of code, and we get this whole report that was generated for us, containing some basic summary of our data. We do get also a tab with alerts for example, high correlation between columns, high percentage of missing values, unique values, or high percentage of zeros, for example. We can also examine particular variables, and the visualizations we get are based on the data type. So, for example, when we're dealing with neighborhood group, it correctly identifies as a categorical variable, so we do get a breakdown of how many listings per neighborhood group. Harder, we get this overview containing some text-based analysis. When we, for example, examine the numerical values, we get the histogram of values. We also get basic statistic analysis, as well as a number of distinct missing values, and so on. Another useful tab is the correlation one. So at the first glance, we can easily identify if there are any columns that are highly correlated between each other. And all of this is pretty much given to us for free with just running a single line of code. We also do get this short summary on missing values, as well as the sample of the data set. And now let's look at the report generated by the Sweetviz library. So in essence, it's pretty much similar. It does have a bit of a different UI, but overall, it presents similar informations. We do also get this associations plot, which does show us the relationship between the columns, and we have this distinction of categorical associations and numerical correlations. So we've discovered one way to streamline our work, and now let's talk about another one. We're obviously in this exciting era of AI where LLMs are taking the world by the storm and are being used pretty much everywhere. So it only makes sense to harness their power to help us in the process of data analysis and visualization. I would say that there are three main areas where we can benefit from using LLMs. So natural language-driven visualization tools. So we can describe desired visualizations or provide instructions in natural language, and the model would interpret and generate the corresponding visual output for us. This approach removes the need for advanced knowledge of visualization tools, making the data visualization process less time-consuming overall. What I mean by contextual visualization recommendations is that language models can provide recommendations for our visualization based on the dataset's content and the user's queries. So by understanding the context of the data, LLMs can suggest suitable visualization techniques that effectively convey the information. And we can also employ LLMs to automatically generate insights from datasets. This streamlines the ADA process by quickly highlighting key findings, trends, and anomalies within the data. So that was a theory. Let's now talk about what the actual tools that we can use are. So when talking about LLMs, it's difficult not to mention OpenAI. Ever since they launched their GPT store, there have been plenty of custom models aimed to support us in the process of data analysis and visualization. So this list is just a fraction of those models. But I'm going to focus on the model actually created by the OpenAI itself, so Data Analyst. So it provides the following functionalities, such as data summarization, coming up with and generating useful visualizations, plot customization and explanation, as well as insight generation. And on top of that, it does provide the code used to achieve all of those goals. However, it's worth mentioning that it's a paid and external solution with a very, very limited free tier. And that does require a GPT Plus subscription for $20 a month. Having said it, I think it's still worth knowing how this tool works. So when you upload structured data, ChatGPT starts by examining the first few rows of the data to understand the schema and types of values which may exist. This is crucial information, as the fact that we do upload part of our data to the model can be a deal breaker for some. So when you ask the questions about your data, GPT performs the following steps. It accesses the uploaded data in the code execution environment, writes Python code to process the data and to produce the required analytical output. It executes code and examines the results and integrates the result into the response that we see in chat window. And while OpenAI enforces using its LLMs, this next tool I'm going to talk about, which is created by Microsoft, called LIDA, is a library that provides bigger flexibility by working with multiple providers such as OpenAI, Palm, Cohere, or Hugging Face. It treats visualization as code and provides a clean API for generating, executing, editing, explaining, evaluating, and repairing visualization code. It's also worth mentioning that the library is open source and is developed under MIT license. So how it works under the hood. This figure comes from a short paper describing LIDA's goals and architecture. So the first component is the summarizer, which converts the data set into a natural language representation. In order to do so, it does sample data. So again, we have to send part of our data to the LLM. But the good news is that it is small samples, so we don't need to spend a lot of tokens when working with external model. Another component is Goal Explorer, which generates a set of potential goals or hypotheses given the context dataset, the dataset context. And finally, this generator is used to generate, evaluate, and repair and filter and execute visualization code. I'm not going to talk about the infographer component as it is in beta and focuses mostly on styling the visualizations. So now let's do a quick demo on those LLM-based tools. Yeah, I uploaded the data, gave me some potential ideas on what I would want to do with it. I asked it to create visualization that it thinks that are most useful, and here's what it came up with. Basically, it gave me a short summary of the data set along with column descriptions, and it produced the following visualizations. So, for example, we have distribution of listings by neighborhood group, which is the visualization I came up with myself. The same goes with price distribution, average price by neighborhood group, which also can give us an insight into how these prices are distributed over particular neighborhood groups. We have a room type distribution and the least useful plot being availability versus price that the model itself describes as a plot with no clear trend. So again, we do get these short descriptions that help us gain more insight into what is being plotted. We can ask it for some more recommendations, and it again creates some more visualizations, and I have to say that most of them are pretty helpful and do make a lot of sense. But now let's show what the LIDA tool can do. So the tool is very easy to set up. It's a matter of simple pip install followed by adding environmental variable with API key and running the simple command to set up the local server. I had no issues with that, and we do get this neat UI that I've already uploaded our data to. Again, we get this short data summary that contains a basic description of our columns. And what's important, we do get this goal exploration tab, where basically the model comes up with the potential hypothesis about the data. So, for example, it came up with what is the distribution of prices across different room types. And here is the plot it came up with. And we do get these 4 tabs that can help us work with the plot. I'll go back to the refine one explain the chart, I wouldn't say it's very helpful, as it doesn't really explain the data, the plot itself, as it focuses on the plot generation part. The evaluation comes in handy when the generated plot contains some errors. So in this case, nothing like that happened. And we also can get recommendation for other potential visualizations similar to the one created. So again, we have this listings per neighborhood group. This one's pretty useless, as it's pretty much a New York City map. We get, for example, average availability of different room types throughout the year, or the distribution of monthly reviews across different neighborhood groups. And we can perform the same actions for all of the generated goals. One cool thing that I like is that we can actually refine our chart. So basically tell the model what we didn't like about the generated plot, and it will try to fix it. So for example, boxes are too squeezed. I can't see them. Let's see if it will indeed resolve our issue. Got a bit better. As it always is the case with live presentations, it obviously didn't do what I wanted it to do. The boxes are still pretty much invisible, but you have to trust me that it did work before. But it is the case with LLMs, as you know, that they don't always do what we expect them to do. Yeah, overall, I would say it's a very cool tool, very simple, intuitive UI. And what's worth mentioning is that all of the functionalities present in the UI can also be achieved via Python API. So these are pretty much all of the code snippets that you need in order to perform the same operations as I did with the UI. Here I've prepared a little comparison of presented tools. You can clearly see the distinction between report generators such as YData Profiling or Sweetviz and LLM-based tools, as the former provide a structured way of examining the data, which is useful when we want to gain a quick insight about the data with minimal effort. LLMs, on the other hand, can provide a deeper and more thorough analysis, but that comes with the cost of, well, first of all, money. To be honest, I wouldn't recommend buying GPT Plus subscription solely to try out the data analyst model, as it is quite pricey. As a comparison, I checked the cost of performing the analysis of our short LIDA example using a LIDA tool, which I showed during the demo, and used around 1,600 context tokens and 500 generated tokens, which, depending on the model, I was running it using GPT, is equivalent to around 0.2 of a cent in case of GPT 3.5 Turbo and 8 cents in case of GPT-4. So if you want to try it out, you can do it at quite a low cost. And that brings us to another cost of using LLMs, as that is sending the data to the model, which is something that either you or your client may not want to do. This is a big advantage of LIDA, as it allows for using locally hosted LLMs that run on your infrastructure. Obviously, if you do have powerful enough GPUs. So I presented 3 different approaches to better understanding your data: doing it manually, which gives us the most flexibility, but is also the most time-consuming; auto-generated reports, which are helpful yet limited; and leveraging LLMs, which can be very powerful, but still comes at some cost. You might ask which one would I recommend, to which I would respond with, why not try them all? Each serve a bit different purposes, so performing manual analysis in some form is pretty much unavoidable. Automatic report generation is a solution that requires the least effort, so pretty much no setup and just a few lines of code. And LLMs are already very powerful and will only improve. So if you have no direct restrictions regarding their usage, I would also give them a try. Thank you very much for your attention. I hope I showed you something new today. And if you were to take away something from this talk, I'd like it to be not being resistant to trying out new tools in order to make your life a bit easier. Thank you.